In the previous video, we've seen some methods of strings, and we created a string called campus equals South Mountain. We used the length method, which is built into the Python core, in which we pass it a string and it tells us how many characters there are. So there's 14 characters in South Mountain. We looked at substring, where we could use a range to pull out characters 1 through 4. In this case, it's going to be 4 is exclusive. It'd be the word out. 1, 2, 3. We looked at the location, where it returns the index of the first occurrence of A in this case, which would be 11. So A is in the 11th index. And then we've seen already we can use lower and upper methods to convert a string to all lowercase, all uppercase. Let's look at some more methods that are in the string class. Maybe not used quite as often, but they can come in handy. So there is a count method in which you can tell what you're looking for. So in this case, I'm going to look for a lowercase o, and I'm going to take campus and convert that to lowercase. So everything here is lowercase. And I want to know how many o's are in that phrase. So count would return 2. There's 1, 2. And we place that into the variable called number of o's, which would be an integer variable. We can also look for a phrase or a substring inside of a string using the word in. So I can look for out in campus. This might be part of an if statement. This is a Boolean expression. So I might say if out in campus, do something. If it's not in there, that would be the else clause, do something else. And the same way I can use a not in. So here, out in campus would be true. I'm going to place it in a Boolean variable. And SMCC not in campus is also true because SMCC is not in campus. If I said SMCC in campus, that would be false. We use the find method to locate the index of a letter or substring in our string. A lot of languages have index of, which do the same thing. And there's an index method in Python that works just like find, but you need to be aware of one difference. The find returns a -1 if it's not found. If index and what we're looking for is not found, it throws an exception. You have to handle that error, and we'll look at error handling here in a future video. So for Python, I'd recommend using find rather than index, and then check to see if it returned a -1. In most cases, that's a better approach than handling the exception. Again, it depends on what you want to do. For the things we're doing, I'm going to recommend find rather than index at this point. Here we have new campus equals campus replace, and I have two arguments here. The first argument is south. That's what I want to search for. That's the old text, and I want to replace that with new text, which would be north. The value of new campus in this case would be North Mountain. So this returns a string and places it into the new campus variable. I've got another string here called ID, which I assigned a value that's all numeric. And there is a Boolean method called isDigit that returns true or false if the string contains only numeric digits. There's also an isAlpha, and the isAlpha returns true or false if these are only alphabetic characters, no digits, no numbers, no punctuation, only A through Z. It can be uppercase or lowercase. And there's also an isAlnum, which contains numbers and alphabetic characters. We've seen we have an upper and a lower method to convert strings to upper or lowercase, but we can also check to see if a string is all upper. So we have an isUpper method, turns either true or false if everything is uppercase. And likewise, there's a isLower method that returns true or false if everything is lowercase. I can check if a string starts with a character or a phrase or a word by using the .startsWith method. And that returns either true or false if that's a match. And again, these are going to be case sensitive. You might want to do campus.lower.startsWith and then make this a lowercase s if you didn't care about case sensitivity. There's also an ends with. So maybe you want to check to see does the input that they entered end with a period. And so we can use the ends with there, and that turns either true or false. We can also have them enter something, and sometimes people tend to put a space after they type something. So there is a strip command, and we can specify what we want to strip at either the beginning or end. In this case, strip does both if it's a space preceding or space after. If you don't specify the quote, space, quote, it'll still remove the spaces. If you wanted a different character here rather than space, you could specify that. You can say I want to strip out any periods at the beginning or end of the inputted value or of the string. There's also an L strip, which removes anything at the beginning, and an R strip, which removes that character at the end. So in this case, remove any spaces at the end. I want to conclude by looking at three more methods of strings, and that is ljust, rjust, and center. And these can be used for spacing output. The ljust left justifies the string in a field of a specified width. In this case, I did 12. So I'd have SMCC on the left and then 8 spaces after that. The right justify works the same way, except it's going to put my text on the right and put spaces in front of that. But I can also add a second argument here, and that is what I want to have precede in the case of rjust, or I could do the same thing on the ljust, what I want to have come after. And here I put a period, a literal string of quote, period, quote, and so it precedes it with periods. And then the next one is center, and again, it's going to center my text inside a field of the number of characters I specify. In this case, it's 12. Let's take a look at this in Python. On the left-hand side is my Python file, and I created 4 clients, and I wanted a name, a phone number, and a balance for each of my 4 clients. Kim Abernathy, Pat Bell, Lee Chance, and Tracy Dragon's Breath. But I want to print out the information of their name, their phone, and their balance across lines with columns. And you can see the effect over here on the right-hand side, what this looks like. And so I simply used a print statement with left justify and right justify. So the client name is left justified, the phone is left justified, and the balance is right justified. And I did the same thing for each of the names. Now you'll notice here on Lee Chance, which was name 3, I just wanted to demonstrate that you could add characters other than spaces. So I did periods here on all 3 of those, and so we get periods going across. There's a little space here and here. That's based on the space that the comma puts in terms of printing out multiple values. You could rewrite this to not use the 3 elements, but maybe just use a string or a concatenated string if you want to get away from those spaces. And then I'm going to show you another way to do this, and that is this last string where I'm using the string format. And we've seen placeholders 0, 1, and 2, but after the colon we can do a less than and a number, and this can be left justified in a field of 24. The 1 placeholder, which is going to be for the phone, is left justified in a field of 18. And then the 2 placeholder, which is our balance, is going to be right justified in a field of 12, and it matches what we had on these print statements up here. And then we use the dot format until we want what we want to print. Basically, that's how you can get columns in your output. In other languages, it's always important to remember that if you're using maybe a GUI interface and you want columns, this should be a monospace font like Courier. That's the default here in Python as far as the shell editor, so I don't have to worry too much about that. And then I want to show you how to use the centering. So I printed a new line character and then some equals going across for 40. And here's my 5 lines, and I just print those out, each line, in a field that is centered of 30 characters. And those 5 lines are all centered with each other.